Well, let's take a look at this question on continuity in 2.6. We're using the graph provided to answer the points of discontinuity on an interval. Now, of special note in this, keep in mind that the interval that they ask you to find the points of discontinuity in does not include the endpoints. So I would never answer that it's discontinuous at 1 and 6 because it's not asking if it's continuous at those points. But any value of x in between could be a potential point of discontinuity. Now, we know points of discontinuity are whenever there is a gap, a hole, or an asymptote in a graph. We have all three of those examples in this one: a gap at 3, a hole at 4, and an asymptote at 2. Now, whenever we're talking about the technical reasons that there's a discontinuity there, we go through our discontinuity guidelines. The first one being that the function has to be defined. And then after that is satisfied, then we say, well, the limit as x approaches a has to be defined. And then the third case, well, the limiting value has to go to wherever the function is defined in order for it to be continuous at that point. So our points of discontinuity here, that's the easy question, the gap, the hole, and the asymptote. That's at x equals 2, x equals 3, and x equals 4. Now, the reason that we have those discontinuities is what they're wanting us to look at next. The first question here asks us to choose the x values that fail the first condition on the checklist. Well, the first condition is that the function is defined. Notice our function is not defined at 2, so x equals 2 fails that criteria. The function is defined at 3. F of 3 is 3, so that's not failing condition 1. F of 4 is undefined, so that does fail condition 1. So we would answer 2 and 4 for that. Now, whenever you're looking at the second and the third, anything that you already say, hey, it's failed condition 1, there's no reason to even think about the other condition. So even if it fails another condition, we don't include it because it's already discontinuous because of condition 1. So for part 2, when it says the limit as x approaches a of f of x exists, I'd say, well, the limit as x approaches 2 from either side is infinity. The limit as x approaches 4 from either side is going to 4. But the limit as x approaches 3, from the left it goes to 2, from the right it goes to 3. So the overall limit as x approaches 3 does not exist. Well, that causes a discontinuity at 3. We would include 3 in our values that fail the second condition. And notice our other two already failed the first condition. So there should not be a 2 in this second answer. So we only want x equals 3 in this answer. And then we've already accounted for all three discontinuities. So the discontinuity at 2 and 4 was because the function was not defined. The function was defined at 3, but it failed condition 2 that the limit didn't exist. And so since we've already accounted for all three potential discontinuities, that last one is no point violates the third condition. You can only violate the third condition if you satisfy the first two conditions. Okay, that would be how we'd work that question. Hopefully this helps it make some sense.